So let us look at some questions based on the domain and range of a given function. So in this question, you're asked to find the domain of f of x is equal to x cube minus 5x plus 3 by x square minus 1 and 1 by root of x plus mod x. So you're asked to find the domains of these two. So what is the meaning of domain? The domain of the function is a set of all those values of x for which the function is defined. So if you look at any function, every function will be made up of some of the basic functions. So in the first module on functions, we have seen different types of basic functions, and we have seen the domains and ranges of the basic functions. So whenever a complicated function is given, you'll have to make use of the basic functions. So first, if you look at f of x is, by the look of it, is a rational function, something by something. And in the numerator, you have a cubic function. In the denominator, you have a quadratic function. So f of x is made up of a cubic function, quadratic function, and this is in the form of a rational function. Now, we know that cubic function is defined for all values of x. Similarly, quadratic function is defined for all values of x. And the rational function will be defined for all values of x except when the denominator is 0. So, if at all there will be a problem in the calculation of f of x, it will be at the places where the denominator will be equal to 0. So, let us solve x square minus 1 is equal to 0. X square is equal to 1. This implies x is equal to plus or minus 1. So, when x is equal to plus or minus 1, the denominator here is becoming equal to 0. So, this function f of x will not be defined. Hence, the domain of this function is simply all real numbers except minus 1 and plus 1. As simple as this. In the next question, if given f of x is 1 by root of x plus mod x. So x is a linear function, mod x is a modulus function, square root function, 1 by square root, rational function. We have 4 different functions that are involved in making this f of x. Now, x is defined for all values of real numbers. Mod x is also defined for all values of real numbers. Root is defined only when the number within the square root is greater than or equal to 0. So, the conditions that you need for this function to be defined is x plus mod x has to be greater than or equal to 0. This is for the square root function. And now you have a rational part also, something by something. And a rational function will be defined as long as the denominator is not equal to 0. That means x plus mod x should not be equal to 0. Root of x plus mod x should not be equal to 0 implies x plus mod x is not equal to 0. So these two conditions should be satisfied. So what is the effective condition? Greater than or equal to 0 should not be equal to 0. This implies x plus mod x is greater than 0. So for this function to be defined, x plus mod x has to be greater than 0. So you need to solve this. You need to see for what values of x this happens. Now, this is an inequation involving a linear function and a mod function. So whenever you have equation or inequation having mod function, we first have to simplify this model. So you have two cases. Case 1, x is greater than or equal to 0. Case 2, x is less than 0. So when x is greater than or equal to 0, mod x becomes plus x. So x plus x, 2x greater than 0, this implies x is greater than 0. In the second case, mod x when x less than 0 is minus x. So x minus x is greater than 0, 0 greater than 0. So this is not possible. So when x is greater than or equal to 0, for this to be satisfied, x has to be greater than 0. So what is the solution for these two conditions? X has to be greater than 0. That means f of x will be defined as long as x is positive. So the domain of this function is 0, infinity. Thank you.